This topic is all about describing polynomials, and we'll start with interval notation. And we did talk about interval notation earlier in the year, and many of you have been using that the whole year. If you haven't, just a quick review. If you look at the left column, this is all our inequality notation. On the right side is the interval notation. And just remember, if you do not have an equal to, then it is the parentheses, but whenever you have the equal to, you're using brackets. So here they are both not equal to, so they're both parentheses. Here we had two equal to's, so they were both brackets. Here we had a not equal to, so it's a parenthesis first, and then an equal to second, so it's a bracket second. And just remember, if this is saying x is less than 5, so the largest number it can be is 5, but not equal to it, so that's why we have 5 on the right side with the parenthesis. And then that means it's anything less than 5, and the smallest possible number there is negative infinity. So that's why the negative infinity is on the left. And again, you can never equal your infinities. On the other side, if we said x is greater than or equal to negative 3, that means negative 3 is the smallest it can be. It's equal to, so we have the bracket. And then anything greater than negative 3, the largest number is positive infinity. Again, you can never equal that. So you can see those. Just remember, the parentheses means not equal to, brackets means equal to, and we can never equal our infinities. So therefore, we're always using parentheses when dealing with positive and negative infinities. So the next part is inequalities, solving inequalities, and then using interval notation to write them. So if we look at our first one, 3x minus 7 is less than 14. I'm just trying to get x by itself, so I'd add 7 first. Get me 3x is less than 21, divide by 3, and I would get x is less than 7. Now from there, that means my largest number can be is 7, but it can't equal 7, and it's every number less than 7, so the lowest it could possibly be is negative infinity. So if I wrote that with interval notation, it would look like this: parenthesis negative infinity, comma 7, parenthesis. Again, we have the parentheses for both because we can never equal infinity or negative infinity, and we don't equal the 7 because there's no equal to in the inequality. If we look at the next one, I would add 2 first. Sorry, subtract 2 first because it's a plus 2, so I'd subtract 2. Give me 18 minus 2, which is 16, so I get negative 4x is less than or equal to 16. I would divide by negative 4. Now the one thing you do have to remember, when you divide by a negative, you must flip the inequality sign. So that would give me x is less than or equal to negative 4. Again, 16 divided by negative 4 is negative 4. And then I had to flip that inequality sign because I'm dividing by a negative. All right, and then from there, if I write that as interval notation, it's saying x is greater than or equal to negative 4. So negative 4 is the smallest it can be, and it can go any number larger than that, so it'd go up to infinity. So I have a bracket because it can be equal to negative 4, and then it can go all the way up to infinity. And then our last one, this is a compound inequality. So I'm going to just do the operation to all sides. So here I would actually add 6 to all sides because I want to get rid of that minus 6. I'm trying to get the x by itself. So I'd add 6 to all 3 sides, giving me 10 is less than or equal to 2x, which is less than 16. I then want to get the x totally by itself, so I divide everything by 2, which would be the same as 5 is less than or equal to x, which is less than 8. So that's telling me 5 is the smallest it can be, and it can equal 5. Can go all the way up to 8, but not equal 8. So that would give me an answer that looks like this: bracket negative 5, comma 8, parenthesis. All right, next is our domain and range. Again, we have done domain and range pretty much all year, so this should not be too crazy for you. Quick review of that. Domain is left and right. It's your x values. So if we look at this first graph, it's going left forever, it's going right forever. So I'd have negative infinity to infinity, parentheses for both because you can never equal those infinities. Your range is your y values, which is down and up. So the smallest y value is how far down it goes, which it goes down forever to negative infinity. And then it goes up to right here, which is a y value of 4. And it does touch an equal 4, so we'd have a bracket with the 4. With the second one, domain is again left to right. It goes left to -2. But notice the open dot, which means it's not equal to, so I have a parenthesis for -2. It goes right to +1 here, and it does have a closed dot there, so it'd be touching 1, which is why I have a bracket. So -2 to 1, including 1, not including -2. And then our range, it goes down to -4. There's an open dot there, so that's why we have the parenthesis. And it goes up to 5 and includes every value in between there. So we have the 5 up there with the bracket. And then last but not least, we have the third one. It goes left to -3 and right forever to infinity. Includes every number in between. It's a closed dot, so we have the bracket. Never equals infinity, so we have the parenthesis. And then the range, it goes down to -4. Again, it's the y value of -4. And then it goes up to infinity. Alrighty. Just remember, the next topic now is going to be increasing, decreasing. And we did increasing and decreasing in the beginning of the year as well, but we did increasing and decreasing with pretty much just parabolas. So now we're going to be looking at increasing and decreasing with our polynomials that are increasing multiple times or decreasing multiple times. So just remember, when you read a graph, you always read left to right, just like a book, and our interval notation is how we're going to do this. So I'm going to start on the left, and if you notice, I am going downhill first. So that means I'm going to decrease beginning. So I'm going to go here where it says decreasing. You were always describing increasing, decreasing with your x values. So I'm going to put an x in there just to remind me that I'm using my x values. And then what x value does it start decreasing at? Well, there's an arrow here, so I could go all the way left forever. So it's decreasing at starting from -infinity, and it stops decreasing right here. Again, I'm looking at my x value, so it stops decreasing at this x value of -3. And again, at the x value of -3, it's flat. It's not increasing nor decreasing, so that's why I have a parenthesis and not a bracket. And then right here, it starts to increase. So again, I'm looking at my x values. So at this, which is the x value of -3, and it increases to right here, which is an x value of 0. So the x value is from -3 to 0, it's increasing. Again, at -3 and 0, it is not increasing nor decreasing, so therefore I have parentheses for all that. It then decreases again. So the way I'm going to write this, I'm going to put this little u here, which means union. It's basically a mathematical symbol for and. So it's also going to decrease from the x value of 0 to right here, which is the x value of 2. So it decreases from here to here. If you look at the x values, 0 to 2. And again, we're always using those parentheses. And then it's going to increase, so I'm going to put that union again from the x values of 2 to infinity. All right, just a couple things. When a function is increasing, the graph goes up from left to right. So again, here's it's increasing, it's going up from left to right, up from left to right. And when it's decreasing, it goes down from left to right. So this is decreasing, going down from left to right, decreasing, going down from left to right. A couple more examples for us here. For this first one, it's increasing to start. So again, I'm always going to write my x here. Just note that I'm looking at my x values. And so right here is increasing from -infinity because it's going left forever. It stops increasing right here, which is at -3. Again, you're looking at the x values. Again, and we're always using parentheses because at those values, it's not increasing nor decreasing. It then decreases between these two intervals, which is a -3 to a +3 in your x's. And then it increases again, so I put that union sign, 3 to infinity. All right. The bottom one is a little tricky. This one is actually increasing to start the whole way from -infinity. And there's an asymptote here. There's a vertical asymptote here and another vertical asymptote right there. So it's increasing to +1. And then if you look down here, it's also going to increase again. So I'm going to put my union from 1 to 2. But again, at 1, the graph isn't touching 1 because of that asymptote, so we have to write it as 2 separate intervals. And then we're decreasing from 2 to 3. Again, we have that asymptote, so it's not touching 3, but then it's decreasing again from 3 to infinity. All right, next is what we call relative or absolute extrema. Extrema just is the plural of extremes. So we're talking about minimums, maximums, and the word relative versus absolute. So let's go over our definitions before we label these. So first is an absolute maximum is the highest point on the entire graph. So nothing higher, kind of like Mount Everest is the highest mountain in the world, the highest point in the world. So therefore, there's nothing higher than it. You have local hills around you that are high, but not nearly as high as Mount Everest. So this is the Mount Everest of everything. So we look at our graph here, we're looking for the absolute highest point, nothing higher than that. So that's right here. So we call that the absolute max. We also have what's called the absolute minimum, which is the lowest point on the entire graph. So that's like your Death Valley if we're talking about the United States, the lowest point on our graph, nothing lower than it. So we have low spots in our area, but nothing lower than something like Death Valley. So right here's our low spot, nothing lower than that on the entire graph. So we call that the absolute minimum. And then we have relative maxes and relative mins. So a relative max is a high point at a particular part of the graph, which is like a peak. So it's like a mountain or a hill near you. It's the highest point. Top of the hill is the highest in that area, but it's not nearly the highest in the world. So we're looking for a high point in this area. So right here, this is going uphill and all of a sudden it goes downhill. So this is a high point, but it's not the highest on the entire graph. So this is a relative max. And also right here, since there's no arrow, this is also a relative max. It's not going on forever. And then our relative min is a low point at a particular part of the graph, which is like a valley. So a low point near your house is not the lowest part of the world, but it is a low part in relation to your house. So since this does not have an arrow, that is a low point for the graph. So it is a relative min. And this is also going down and comes back up. So right here is a relative min because it's a low point, but not the lowest for the whole graph. All right, so some practice. It says identify the ordered pairs. Change that x values to ordered pairs if you have not done so of any relative or absolute extrema. You're going to do number 2 on your own. I'm going to do number 1 with you guys. So our absolute max is the highest point on the entire graph. So right here is the highest point in the entire graph. So I'm going to label it as an ordered pair. The x is clearly 2. The y you just have to approximate. So it's definitely a little bit above 4. So I'd say maybe 4.2. The absolute minimum is the lowest point on the entire graph. Now if you notice, this is a low point, but these have arrows here. So it's going down forever. So there is no absolute minimum there. The relative max is a high point, but not the highest point. So this is increasing and then it comes decreasing. So this is a high point for that particular part of the graph. Again, we're going to label with the ordered pair. So it's -3 and -1. -3, -1. Then a relative min is a low point for the graph. So right here is a relative min. Be -1, roughly -3.5. You know, your y values don't have to be exactly the same as mine, but should be relatively close. All right, you're going to do number 2 on your own for practice. One more example here. This kind of combines everything together. So first it talks about domain and range. So domain is going from -infinity to 5. There's a closed dot, so we have the bracket there. The range is going down forever and up to 3, so from -infinity to 3. Your x-intercepts, we have to approximate. So right about here, about -2.80. Right here, 0, 0, 3.2, 0, and then 4.5, 0. And I have y-intercept right here of 0, 0. That's where it's crossing the y-axis. We have relative maxima. Maxima just means the plural for maximum. So there's two of them. So right here, it's a high point, but not the highest on the graph. So at negative 2, 2. Right here at 2, 1, a high point, but not the highest point. I have relative minima in this case as well. A low point, but not the lowest on the graph. So right here is a relative min 0, 0. A low point right here, 4, and I just wrote comma 0.8. So that 0.8 can be, anything close to 0.8 would work. Absolute max and absolute min means the highest point. So the highest point on the graph is right here at 5, 3. Absolute minimum means the lowest point. Now there is no one point that is the lowest because it goes down forever, so that's why there's none for that. And then our increasing, decreasing. So we are increasing to begin with, so it's increasing from x values between negative infinity and negative 2. It increases from 0 to 2, the x values, and then it increases from 4 to 5. The decreasing, it decreases from the x values of negative 2 to 0, and then again it decreases from 2 to 4.